Hey everyone! So, what if I told you that the computer you're using right now could secretly be dozens of different computers, all of them running at the exact same time, but totally separate from each other? Sounds like science fiction, right? Well, it's not. It's the power of virtualization, and it all kicks off with one simple but pretty wild question.
I mean, really think about that. Taking one single physical machine and then safely and super efficiently running multiple completely separate computers right inside of it. This isn't just a cool idea. It's the reality that powers so much of our modern world, from these giant data centers all the way down to the laptop on your desk.
So this magic of having computers inside of a computer, it actually has a name. And it all begins with this concept called the virtual machine.
At its heart, virtualization is really just the process of creating a virtual version of computer hardware using software. So instead of going out and buying a new physical server, you just create a software-based one that acts exactly the same way.
And that software-based computer, that's what we call a virtual machine, or a VM for short. Here's a great way to think about it. Imagine your physical computer is a big office building. A virtual machine is like a completely independent office suite inside that building. It's got its own walls, its own power, its own security. It just happens to be sharing the building's main foundation.
Now, to keep all this straight, we use two really important terms. The host is the physical machine itself, that's our office building, and the guest is the virtual machine running inside of it, that's the individual office suite, and each guest can run its own operating system, totally independent from the host.
So you're probably wondering, how does this actually happen? How does one physical machine share all its resources without everything just getting totally tangled up and crashing? Well, it all comes down to a very special and absolutely crucial piece of software.
That software is called the hypervisor. And if the physical machine is our office building, then the hypervisor is the building manager. It's the software that actually creates those virtual office suites and then manages everything, deciding how much electricity, floor space, or in our case, CPU power, memory, and storage each little office gets.
And the process itself? It's actually surprisingly simple. First, you install that hypervisor software. Then it creates what's called an abstraction layer over the hardware. And from there, you're pretty much ready to create and launch as many virtual machines as your hardware can handle.
So how does it manage all the resources? Well, here's the really clever part. Each VM truly believes it has its own dedicated hardware, a virtual CPU, virtual RAM, a virtual disk. But in reality, the hypervisor is in the background, cleverly mapping all of those virtual parts back to the single physical hardware of the host machine.
Okay, so we've got the how, but now let's get into the why. What makes this one of the most important technologies in computing today? Turns out it's not just about being efficient. This is the invisible backbone of the entire cloud computing industry.
And I'm not exaggerating. This isn't just some neat little trick. Virtualization fundamentally changed how we use computers. It allowed us to do so much more with the hardware we already have. It's a true game changer that basically makes the modern internet possible.
And you can see that impact when we look at how it's used every day. Let's just quickly touch on four of the biggest ones. Saving a ton of money by consolidating servers, safely testing new software in isolated environments, running any operating system on any computer, and even making disaster recovery way simpler. Okay, first up, server consolidation. You see, in the past, a new application often meant buying a whole new physical server. With virtualization, you can run dozens of virtual servers on just one physical machine. The savings in hardware, electricity, and just physical space are, well, they're massive.
And the effect is pretty dramatic. I mean, look at this. Instead of needing a whole rack of 20 servers, a company might only need one or two powerful machines to do the exact same amount of work. That is an incredible leap in efficiency.
Next up, testing and security. Because VMs are completely isolated from the host system, they create these perfect little sandboxes. Developers can test new, unstable code without any risk to their main machine. Security researchers can even set off computer viruses inside a VM, knowing that any damage is totally contained and can't escape.
And what about flexibility? Oh yeah, virtualization just shatters the boundaries between operating systems. Do you need to run a piece of Windows-only software on your Mac? No problem, just run a Windows VM. Need to test a website on Linux from your Windows PC? Just spin up a Linux VM. It's really that simple.
So let's zoom out for a second. What's the big picture here? What's the single most important thing to take away from all of this?
At the end of the day, virtualization is the ultimate force multiplier for computing. It lets us maximize our hardware resources, giving us the power to do so much more with so much less, all while making things safer and way more flexible.
It really all comes down to these three core benefits. You've got efficiency, through all that server consolidation and cost savings. You've got flexibility, by letting any OS run anywhere. And you've got security, by creating those isolated sandboxes for testing. It's a technology that truly delivers on all fronts.
And that brings us to one last thought. We've mastered creating virtual hardware. The ability to just take a computer apart and rebuild it entirely in software is an incredibly powerful idea. So the big question for the future is, what else can we virtualize? And what incredible new possibilities will that unlock?